I'll start at 2 o'clock, but pretty handy if you don't know what super hot is. Okay, cool. So super hot was made by 4 guys. Never made a game before. They're just software application developers, and they just decided to download Unity and just try and make a game which has quite possibly the most simple game mechanic of all time. Basically, as you move, time moves. So if you stand still, basically time is all pause, and then as you tiptoe, time counts, and as you walk, time is all your speed. So yeah, they made, it's like one line of code, and they basically made a mechanic which just shits on the G. So yeah. So as you move, so you have the bullets in the glass. You have to run down the corridors. But the trouble is that you shoot a bullet and you have to move to let the bullet travel. Yeah, it's sort of like a shot. So the cool thing is they're going to make Oculus Rift versions. So what you'll do is you'll stop and you'll see all these bullets just traveling past your head, and you have to like duck these bullets and then shoot a guy. It's going to be amazing. And throughout the prototype they made, it just says super hot, and everyone in the office was playing it, just walking up to each other going super hot. And people were making coffee, and yes, people were like, what's that coffee like? Is it super hot? We're not very funny. No, it's fine, guys. Yeah. Okay, so I'm going to start again. What point did we get to? We got to the most interesting wallpaper in the world. Yeah, so I can take this game, I can ship it on like an Xbox One and then charge people money for like, I'll call it some obscure French name or something, I don't know. USS Patata Enterprise. So yeah, super simple spaceship. So what we want to do is we're going to do a couple of things. We want to write scripts, we want to write code to actually make our ship move. Because currently it's very boring. It's just going to sit there and the renderer is going to say, this is a spaceship, this is a background, and so on and so forth. It's just going to sit there very motionless. So what we're going to do is going to resize it. It's quite easy to do. So we've already done this once before. So what you'll notice is that even though the team view, if you scroll, is super zoomed in, then you'll see view there and you think, oh, my ship is big enough, it's amazing, it's nice and beautiful. It's still that small, that's what the players can see. No, they don't care about this, they care what's in the game view, because that's what they see in the end, that's what they assess your game by. So what I'm going to do, and what you guys that are following I'm going to do, is select the potato bat, or select what you do with the ship, and then just resize it. So I'm going to just grab one of the corners, scale it up, and then I'm going to position it somewhere at the bottom of my screen. Thank you. Cool. So I'm going to position it somewhere at the bottom of my screen. So what you'll notice is that my ship's a bit bigger if I go into plane mode. Spaceship. So yeah, it's a bit more of an interesting wallpaper, a bit more of an interesting app. So yeah, I just have spaceship bottom. So the end goal is going to be our spaceships to move from side to side, Space Invader style. And you can have some asteroids or targets that you can fire at. So it's one of the most simple games you can make. Or we could have made 5 to go. Cool. So we've got a spaceship like that. Now, by default, Unity has a full scripting API, which allows you to pretty much access any sort of component, access any sort of like item within Unity and do something with it. So for example, I can write some script that goes to my spaceship and, for example, changes the color over time, changes the position, changes the scale. I can write a script that accesses these things very easily. So what we're going to do is we're going to write a script, very, very simple script. That's you're going to say push left or right. If you push left, go one way. If you push right, go the other way. It's the easiest code in the world. So, pretty handy if you're terrified by code. Oh, this is going to be awesome code. Most people are like, someone like was like had a tear in their eye, she had to write code, and people get very scared by code. Yeah, cool. So yeah, so we're going to make a simple script. So I like to keep things nice and neat and ID. So bring your hand up again if you're a student. Okay, do you want to know, bring your hand up if you're a teacher. Okay, I can tell you secrets. Okay, so when you're a teacher marking students' work, the students that just call everything untitled, untitled, untitled 1, untitled 2, untitled 3, those students get lower grades than the ones who name stuff correctly. Yeah. So if you call like your spaceship untitled, you call your rockets untitled, and you call your scripts untitled, you call your textures untitled, or untitled -1, -2 dash, don't use this one -finished, which everyone's always done at some point. You know, those teachers don't like marking that sort of stuff. If you name everything accurately, teachers will love you a lot more and you may get the marks. So yeah, I'm kind of cheating the system here, but luckily my teacher isn't here, or my old teacher isn't here. Yeah. So what you'll notice is that we have files for our sprites, fonts, textures, app icons, audio, and things like that. So we need to create some more folders. We need to keep things nice and organized. So I'm going to go to my project folder, which is this one here. I'm going to go click create. And you notice that there's a folder option. And I'm going to make a folder, position it next to my other ones. I'm going to call this folder. Okay, I'm going to call my folder scripts. Oh yeah, so we've now got a new folder for scripts. This is going to hold all of our scripts. We're going to write 2 scripts because we don't have time to write 2. In the finished version, it has like 5 or 6, which I can just give you guys. You can have a look and see how I've done it. So this scripts folder is going to hold all of our scripts. What do I? Okay, so for lunch, I mean for like, I don't know, for a clap. I don't know. Can anyone tell me what a script is? It's not something actors read. Just go for it, yeah.
It's code that you run.
Code that you run, yes. Yeah, okay, that's, yeah. Cool, go for it.
Well, script in the terms of game engine is usually when... Okay, that's a stupid explanation. It allows you to custom... well, whenever there are events that the game engine is throwing at you and you can react them to customize the behavior of the game.
It allows you to do stuff, right?
Yeah.
Yeah, cool. Cool. So what we do with Unity is it has a scripting API that allows you to have an object, attach a script onto it, which is a behavior, which then controls everything around the object. So for example, we can have a script on the spaceship, and that script is going to give the spaceship lots of commands and rules and behaviors and controls. It's going to say, when we push a button, the spaceship is going to do this. When we push a different button, the spaceship is going to do this. When the spaceship hits an asteroid, the spaceship is going to do this. It's kind of like each item has a script to say what it's going to do. So for example, this coffee would have a script in it to say this is going to wake Andy up, for example, when Andy drinks it. So we're going to place a script on a spaceship, and we're going to place a script on our rocket. So what's going to happen is the script on the spaceship, when we hit spacebar, we create a rocket, and the script on the rocket is then going to tell the rocket to fly. So it's going to have different objects and different scripts.
No feature.
Yeah, it's hardcore mode. Okay, yeah. So basically, you write a script for an object. Now, because of the way that the scripting API works, you don't have to write a separate script for every object. So, for example, when we spawn like 1,000 rockets, you don't have to write rocket 1 script, rocket 2 script, rocket 3 script. Because it works in a class-based system, you can create one script, which is basically an overall thing for all other rockets, and they will have their own behaviors from that script. Okay, cool. So let's write some code. So what we have here is we have our scripts folder. Cool. We're going to create folder. And you'll notice here that we have several different types of script, or several different types of code you can plug into Unity. So the JavaScript one is kind of like, it's not really JavaScript, it's like weird fake Unity JavaScript. I know like there's like 0.5% of our users actually use this, so they use it. Boo, I've only ever met 2 people who write Boo in Unity, and they work at Unity, writing the Boo API. No, I did meet one guy and he was like, I'm switching to Boo. So yeah. So whenever I meet them, they're always like, So how many Ruby developers have you met? I'm like, couple? Yeah. C# is what pretty much everyone writes in Unity. You can also write your own shaders and things like that, but I'm not going to get into that because it's a completely different ballpark. So what we're going to do is we can create a C# script. We're going to call this script something accurate, so in this case, spaceship control. Basically, this is going to be the script that sits on the spaceship, tells the spaceship to do stuff when we put stuff in. I've tried to make code sound fun. It's very fun. So what we need to do now is we need to now type in code. We need to basically give these instructions. It's not as simple as like a build spaceship code button. Unfortunately, that doesn't exist. Otherwise, we have a billion spaceship clones, which we will have. But yeah. So spaceship control, we have to type some code into it. So when you download Unity, it comes with a code editor called MonoDevelop. I don't like MonoDevelop. I'm allowed to say that. So I don't like MonoDevelop. So you can actually use whatever scripting editor that you want to use. So for example, if you want to use Notepad, Visual Studio, Sublime, so I'm going to use Sublime. Basically, you can choose which scripting editor you want to use. Some guy has uploaded a video for scripting in Microsoft Paint, and then importing that somehow. It's like, how the hell did you do that? It's like he said, I wouldn't recommend it, but it's just fun. So he scripted in Microsoft Paint the cube that span, and it took him ages because he had to set up like loads of crap. Yeah. So what happens is, by default, MonoDevelop is selected, but if you do have your own machine, you prefer like Visual Studio, you prefer a different script editor, to change your script editor, go to where it says Unity and Preferences, or somewhere there's Preferences, and you have this window. So somewhere Unity Preferences, or it might be under Help Preferences or File Preferences if you're on Windows, and go to External Tools, and you'll notice here it says External Script Editor, and then you just point it to where you want it to be. Point it to, I don't know, Paint, or I'm pointing to Sublime. By default, it's MonoDevelop. You can still use MonoDevelop if you want, but most people switch to like something else because they prefer something different. I prefer Sublime. So you can switch it if you want. Yes. Cool. So what we have now is we set up our scripting editor. What we need to do is double click on the script, and it will open the scripting editor. So what we have here is the scripting editor sits outside of Unity. So you have your Unity, like almost Unity shell, which has all your sprite editor, your game, your scene view, all your projects, your assets, and things like that. The script editor is separate from Unity. That way you can basically use whatever script editor you want. Some people don't want to be restricted to a particular one. So what we have here is we have our Unity project, we have our script editor here. And Unity is very, very quick. So as I type some code in here, I save it. As soon as I go back to Unity, it will point, if I have no errors, it'll instantly update the script, like straight away. So you can write some code, so I can go, go in here. Oh, I can save it, yeah. So I can write, save that, go back to Unity. Oh wow, look, at the bottom, Unity is already pointing out posting load of nonsense. So rather than it being like other programs where you type some code and then it will have an error and then it will just say there's an error, deal with it basically. What Unity does is it actually points out on that line of code which line of code has the error on it, and it tells you exactly what that error is. So if I mistype something, if I misname something, Unity will point out that mistype, that mistake. So you'll notice here it's actually saying assets, spatial control, line 5, error code, unexpected symbol, and then I can go, okay, really? And if you double click on that error, it will actually just bring up your script editor and it will highlight, yeah, it's this bit here, like that's the nonsense. So yeah, so we can write some scripts, pop into Unity, check what it does, go back, write some more scripts, pop in. So it's very quick going back and forth. So what I'm going to do now is I have this spatial control script. I'm actually going to write some code in it. So pretty handy that you've never written code in Unity before. A couple of people. So pretty handy that if you have. Everyone must have put their hand up at some point. Some people asleep. If you put your hand up, like, come on, man. Must be asleep. Cool. Oh yeah, okay. So most of you are written code in Unity before, but I'll go through this very, very quickly. So what we have here is a start function. So start function will trigger things at the beginning of the game. So this will be like place the enemy like at the end, place the boss, reheal the player, check what his high score is. That's what start does. It's what happens at the beginning of the game. So if at the start of the game, I want my spaceship to fade in, or I want my spaceship to be positioned somewhere I have full health, either stay to there. Update runs every single frame. So basically this is the thing you check. So you check every single frame, like how about push spacebar? No. Then when I push spacebar, he goes, yes, push spacebar. Let's do some cool fun stuff. So you normally start with like setting up things, and updates will kind of like repeatedly check if certain, like if you have 0 health, you have 0 health and die, for example, and stuff like that. So what we're going to do is we're going to write some very simple code. So I'm going to open it up. I'm going to write a public float. Public float. Call this. Cool. So we have a public float force. So what you'll notice in Unity is it's very friendly for designers. The reason being is because I used to work like help making a Lego game, and I'd like write some code, and then the designer will come over and then like basically change the code, and they have no idea what they're doing. So when I come the next day, there's loads of errors all over my code, and I'm like, well, cheers designer. And they're like, oh, we just wanted to tweak how frequent an enemy appeared, or we just wanted to tweak this. And those are the tweak stuff, but they never do it correctly. So what Unity allows you to do is it allows you to expose certain variables and certain properties for your designer to play around with. So for example, here, I'm setting up a variable public float, so floating decimal point force. If I set up some other public things, so public, color, ship color, and I set up public animation curves. So you don't have to animation curve, curve. So you don't have to type this in, I'm just using this example. So I set up those things and save it. If I go back into Unity, and take my spaceship control script and attach it onto my ship. So you'll notice my ship here. So you take the spaceship control, drag and drop it onto your spaceship, so now it becomes the behavior of the spaceship. What you'll notice here is that underneath the spaceship control script, as opposed to the designer going into your code and just being like Godzilla and just trashing your code to bits, what you can actually do is you can actually say, don't open my code, just change these variables here. It makes it a very nice and friendly, interface. So for example, the designer can come in, rather than going in and basically going on a massive rampage and start adding loads of nonsense and stuff like that, what the designer can actually do is they can just get the Unity project, have here, so we've got force, so they can fill this in and say, oh, let's have the force of the spaceship to be 6.5, and then they can test it. Well, let's change it to be like 6.6, and they can test it, and so on and so forth. You can also open up other things as well as numbers. So here I've got color, so I can click this number panel, this color panel. It'll basically open up the color panel. And this will basically allow the designer to kind of tweak like the color of a goblin. So if they have a goblin, they can go in and they can tweak a goblin's color to be blue. Without going in the code and setting up like blue for a goblin, they can actually just go, oh, let's have the goblin blue. They can also set up animation curves. So what you'll notice here is if you click the area, so you have the curves. You could, for example, you have a menu slide in, and it would do it normally. So for example, menu slides in like flat. So rather than the designer going in and plugging a load of code to make it smooth or ease in and ease out, instead what they can do is they can go to this nice and easy to use curve editor and kind of like change the different values and move them around. And basically make your menu kind of like bounce in there. So yeah, basically the designers can play around with it. If you don't want the designer to change some code, you can set the variable to be private. So that basically means like they can't view it in the editor. Cool. So I'm going to go back to my code. I'm going to get rid of this nonsense, and I've made a simple variable for force. So this is going to be the speeds that our basically spaceship is going to move at. So we're going to tweak how fast the speed is. I'm going to set up 3 more variables. So the first one is a rocket. The next one is going to be a rocket. Public transform rocket 2. So what we have here is we have, from the script, we've got force, so we've got float value, we've got a number that's going to change, so it's how fast. So if I throw this bottle, I'm not going to do that, because that's horrible. But if I throw it, like what's the force I'm going to throw the bottle at? So our designer can then tweak it in the editor. What we also have here is we have 3 slots. So these slots are going to be things that we're going to create. So in this case, we're going to create a rocket, and we need to tell it where it's going to create it at. That's kind of getting ahead of ourselves, because we haven't made the rocket yet. So basically, I'm just going to leave those there. Everyone got that so far? Yep. Give it a thumbs up. Cool. Some thumbs, some like gladiator style. Like, oh, this rock. Yeah, rock one's cool. Awesome. I said that once. I said, put a thumbs up if you're all okay. And some guy lifted like a slice of pizza. And I was like, how the hell did you get pizza in here? This is amazing. He was like, do you want it? And I'm like, okay. Yeah. Awesome. Cool. So what we now need to do is, now that we've set up these variables, we need to set up our input. So we need to set up one more variable. Oh shit, no we don't. Okay. So what we need to do is we then need to, in update, we need to find out when our user is pushing a button. So update basically runs every single frame. It says, has this happened yet? No. Has this happened yet? No. Is the player dead? No. Is this happened? No. And then when, for example, the player dies, then it goes, aha, this happened. Right, let's kill the player. Let's make an animation. Let's make it go slow-mo and stuff like that. So we need to do an update. So we need to check if our player is pushing left or right. So we're going to make up a fake virtual joystick. So here, we're going to set up a variable of float. So float is going to be anything with a decimal place. So like it could be like 4.5, 5 billion, 0.1. It could be anything with a decimal point. We're going to say float equals input.getAxis horizontal. That looks like a load of nonsense, so I'll explain it in a second. Cool. So, actually, does anyone want to explain it for me? I don't know it, so yeah. Go for it. That way. Yeah. So that would. So if I was going like back and forth, so if I had like a car and you push forward to go forward and back to go back, I'd change this to vertical, so it's like up down, and then horizontal would be left and right. So I could have my spaceship go up and down, and then he flies his asteroid and flies up. So yeah. Cool. So yeah, basically here, what we're doing every frame is we're getting the input with the axis of horizontal. And horizontal is like the default built-in Unity input, basically saying left or right. Or if you're a true gamer, A and D, right? I hate the whole left and right A and D thing. It is A and D, that is the true input, but you have to factor in for all our grannies that play the game. Like my nan, my mum. So yeah, my mum's not granny. Cool. So what we're doing every frame is we're defining what the axis is in horizontal, and that's between left and right. So can anyone tell me what the axis of it means? Go for it.
I guess that's marking for controls. That would be, I guess, I don't know how they're normalized between -1 or 1 or between 1 and 0. I have no idea.
You're so close. Okay, so the axis is basically bingo. Yes. So it's like a joystick. So who's got like a flight simulator, not rock simulator, flight simulator with like a joystick and yeah, no one else. Who's played an arcade machine like some Tekken, Street Fighter and stuff? Who's played games in general? Okay, so you know joystick on a controller. Basically what this is doing is it's getting if the joystick is left, okay, it's right, or it's left. So what we're doing is with the left and right buttons, we're saying, are you pushing it left or are you pushing it right? So what I could have done, right, so this is going to be a load of nonsense, okay? So I could have said, if the player is pushing left, do this, if the player is pushing right, do this. But then what if they push both keys at exactly the same time? The ship's going to go like that, and that's horrible. I want to find out if it's one or the other. So what the axis is doing is it's basically finding out which way I'm pushing it, and it goes from a scale from -1 to 0 to 1. 0 to -1. Because it's a float, basically, as I push left, it will slowly phase from 0, -0.5 to -1. So basically, our ship is going to build up momentum over time, and it's going to go the other way, so it's going to go momentum the other way. So yeah, we basically have this whole axis in place. later on I'll show you, okay, so I'll show you quickly. So if you're thinking like, why the hell is it called horizontal? Where do I change this to like kick out to joystick or whatever? Basically, in Unity, if you go to File, wrong place. If you go to Edit, Project Settings, here is also like the background bits and pieces of Unity that you can play around with. So this is how super hot is made. So for example, if you go into time, you can tweak what the time scale is of the game. So you could write in the code, as the player pushes right, speed up time. As the player pushes left, slow down time. So now everyone's going to make super hot time happy, right? This guy's like, oh yeah. 200 grand on Kickstarter, yes. So this is all the background bits and pieces, like you can play with physics, you can play around with quality and graphics and stuff like this. So for example, with Hearthstone, they get whether you're playing on like an iPad or they get whether you're playing on a desktop, and then they change the quality depending. So if you're on an iPad, obviously they lower the quality levels. If you're on a desktop, they up the quality levels and have more things. So if you go into the input section here, what you'll notice in the inspector is we have a load of pre-built inputs. These will be things like horizontal, which you can see here is like left and right. Vertical, like you were saying, is going to be up and down. Or like this is left or right. Alternative is A and D. I should really get the guys to change this the other way around. Because left and right should be the alternative one, and A and D should be default. But gamers. We also have, for example, fire 1 will be like left mouse click. So if you want to like write, if the player has pushed fire 1, that would be left mouse click. I could change this so I could say fire 1 actually isn't mouse, it is actually H. So every time you push H, that is fire 1. So you can make up your inputs. You can make up jump, you can make up roll, you can make up like high five. You can basically make up your own inputs and things like that. So that's what it means by horizontal. So when we push whether left or right, it's going to go to this slot in the input. It's going to say, is it left or is it right? So you've got the negative or the positive. And then it's going to say, like, yeah, get what the axis is. Awesome. So it's right. Cool. So we're getting the axis. Super boring. Let's actually do something with it. So now that we have the value, what we need to do is we need to split the value. So we need to say, if the axis is going more than 0, so it's going to 1, go right. If it's not, go left. So simple if statement, if H is less than 0, so it's going to the left, then I'm going to just write a little code comment in saying, go left, or go left. Yeah, go left. And then I'm just going to put a simple if. Else, if H is greater than 0, go east. Right, cool. So basically what it's going to do is it's going to get the input, and then it's going to say, if the input is less than 0, so it's going to the left, trigger this code. If the input is going to the right, trigger this code. Now some of you here are like pro-programmers, or programmers. I'm probably looking at this saying, I could do that, but what do I do code? Well, go for it then. Like, it will compile the same anyway, so yeah. Cool. So yeah, I'm just going to do it this way. So yeah, go left or go right. Cool. And we now need to do one more thing. So what I could write here is I could write in the value. So what this update's going to do is it's going to say, is it less than 0? Is it less than 0? Is it less than 0? Well, if it is less than 0, trigger some code. Now I could write in here, for example, do this, do this, do this, but I don't want to do that. I want to make a separate function, so one that's not inside update, one that's not constantly running, and call that function when I go a certain way, and pass it direction. So I'm going to make, underneath update, I'm going to make a function called void apply force, and I'm going to make a separate function. And that function will only trigger when I say apply function elsewhere. So the reason why I'm doing this is because if I was to make like a mobile game, what I can do in update is I can find out if my player is using it on like if my player is on a device like this or on a desktop. And then that way what I can do is I can have the apply force function outside, so I can say if it's tilting, apply force. If I'm pushing left to right, apply force. If I'm on Xbox controller, apply force. So that way I don't have to write the same apply force function 3 times, I can just write it once. That probably was wrong. Other people's okay. Cool. So yeah, what I can do here is I can say go left. So what I can do is I can say, if it's there, go run, apply force, and then what we can do is we can actually pass it a value. Because if I just say in both of these slots, apply force and apply force, for example, it's just going to apply force. What I need to do is I need to say, if it's going left, send in the message saying apply force, go in the left direction. If it's going right, apply force, go in the right direction. Okay, that was right and left to me, but yeah. Cool. So this is very easy to do. What we have to do is we have to write in here the vector 2 direction. So yeah. So this bit's a bit tricky. I understand that this code stuff is a bit strange. So what is happening here is we have a function of applied force. Inside here, we're getting the value, vector 2, and we're giving it a direction. So what vector 2 means is it means x or y. So it's basically giving you two values. It's either going x or it's going y. If it's vector 3, it's x, y, or z, for example. It's in the 3D space. It's probably a vector 1. I don't know. So vector 2. So what we're going to do is we're going to say which direction it's going to go in. We're going to send it from here. So in go left, we're going to say, in go right, we're going to say vector 2, right. So what that's going to do is, if we push that and it's greater than 0, it's going to go on this function, it's going to say go right. But go right. In the other one, what we're going to do is, this doesn't make any sense, right? Is go vector 2 to right minus. So it's going the opposite way of right, okay? I have had so many conversations with the 2D guys to say, I've had so many conversations with 2D guys to say, why no work, right? And I'm like, why is this not work? Why so serious? Like, why do we not have vector 2 to left? And they say, yeah, we'll do it at some point. So if you guys send enough emails to them and hassle them, they get stuff done. That tends to happen in Unity. If enough people moan about something, it will happen. So yeah. Yeah. That's why with the 2D tools. So basically, we had so many people, so many companies like Rovio and so and so saying, we want 2D tools, we want 2D tools, we want 2D tools. So then they were like, okay, we'll do it. That tends to, yeah. I mean, could you do that with Apple? Did they change iOS 7? Yeah, we'll change it. Yeah. So yeah, anyway. So what we're doing is we're going to say right, go right. This one, go minus right, so go the other way. I'm aware that that doesn't make much sense. So what I've got this project finished. Every single line of code, including the if statements, code commented with like explaining the exact stuff. I can show that at the end if you guys want. Or you can just send me email saying this is stupid, why is it vector 2 left? Yeah. I think it's good as well. Yeah. You could. Or our developers can just Cool. So yeah, void apply force. So now we've set that all up. Actually, that's the most complicated bit of code we'll be running. Next, we then need to do something with it. So we have the direction, we have the force, now we need to apply it. So what we need to do is we need to say, add a rigid body to our spaceship. So we have that all code, but it doesn't really do anything when we push in a certain direction. So let's go back into Unity. And you'll notice on our spaceship, our little potato hat thing, if we select the potato hat and we go over to the inspect on the right hand side, we have its description. So if you haven't already done, you take the script and then drag and drop it onto the potato bat. And you'll notice it's got a description. It's got things like where its position is, what its rotation is, what its scale is. It's got its sprite render, so how it's rendering. Is it red? Is it blue? What's the color of it and stuff like that. And underneath there we have a script and the behavior to say what it does. So you'll notice here we have lots of slots here. So what I can do now, for example, is I could then write some code that basically accesses another component. So I could write some code that says something like, when we do this, go to the transform component, go to the position of the transform, and make it equal 6. So that means whenever I push that any button, left or right, it will set its position to be 6. Right? Completely useless, because then our ship's technically not moving, it's just teleporting to a location. What I want it to do is I want my spaceship to have physics, because if you think about it in space, like, no one can hear you scream, but also the fact that like you move it, and then it will just keep sliding. So I want to apply gravity onto my spaceship, and what I want to do is I want to apply gravity to my spaceship. When I push left, push it with gravity going left. When I go right, I'm going to do it for you guys, and then you push it going left the other way. So yeah. So it's really easy to do, because currently our spaceship is, the potato is sitting there, being a potato. So what we need to do now is we need to tell our spaceship have some gravity. And this is really, really difficult. Okay, so you're starting to learn that when I said you were difficult, it's actually quite easy. So go down to this spaceship here. So select spaceship. We have all things to describe the spaceship. And we're going to add a new component. So this is a new description of the spaceship. So for example, if I took like some bunny ears and put them on my head, I'm adding a component of bunny ears on my head. And then I'll add a component that he looks like an idiot, and add a component of like, yeah, he looks like he should take them off, and so on and so forth. So what we're doing with the spaceship is we're going to say, you're being rendered, you have a position, you have some scripts, you're going to add a component, and underneath here is all the things we can add to our spaceship. So this is where like Unity really opens up. So for example, if I go into the effects bit, I could add, for example, a halo on my spaceship if it had lights, for example. Like, I could add a lens flare if I had some lens flares imported to make it look like J.J. Abrams like style of Star Trek, or the new Star Wars, which every lightsaber is going to have a lens flare on. I could add like a particle system, so I could have flames coming off my spaceship if it's blown up or something like that. Basically, you can add on lots of descriptions. I could say it renders text, or what else is there? I could say that it has a navigation mesh. I could say that it emits audio with a distortion filter. So as audio comes out of the spaceship, it distorts the audio. It's pretty cool. I can basically build up a lot of stuff. So what instead I'm going to do is I'm going to go to physics. And you'll notice here that I've got two different types of physics. Physics 3D, well, just physics and physics 2D. I'll talk more about this tomorrow. But I'm going to go to 2D physics. And we have all the things about 2D physics. So what our developers did is, when they implemented the Unity 2D tools, they could have just used the entire 3D physics system and been super lazy. But that's really unoptimized. If you have a game like Candy Crush, where there's lots of physics going on all over the place, basically, that would be really unoptimized using a 3D engine. So they just took native box 2D and implemented it into Unity. Which sounds really casual, but they did that. So what we have here is we have box 2D, but in Unity, automatically in there, built in. And what we have here is we have several things like clones. We can talk about clones a bit later on. But what we have here is we have rigid body 2D. So rigid body 2D, or rigid body, is a component you add to an object to make it have physics. So for example, I have a bottle. If I drop this on the floor, it's got physics. It's because it's a rigid body. It is a rigid body, and if I drop it, it's going to have velocity and force and stuff like that. So if I select rigid body 2D, my spaceship now has a position, rotation, scale. He now has a renderer to render it. He now has a script to control it, and he now has a rigid body to say it's affected by physics. So as simple as that. It's the difference between having a house and a falling house. It's just adding a rigid body onto it. So yeah. So now, for 10 Gryffindor points, who can tell me what happens when I play my game?
Falls down.
Right, I'm like, kick out, oh, shit. I bought this kick-ass car. Shit. So what's going to happen is my spaceship's now going to keep falling. So if I position my spaceship like at the top, it's going to build up momentum, and it's just going to keep falling and falling and falling and falling. And what I said about like the fact that in Unity you can kind of like, you have your scene view, well you'll notice that as I play my ship, play the game, you can actually see it keep falling. I can even pause the game, go to where my spaceship is, and I can actually click the step frame button to actually see where it's going to be next frame. So next frame it's going to be there, this one's going to be there, this one's going to be there. So it's quite useful for like debugging like stuff, so you can see where objects are. Like first game I tried to make in Unity was an MMO, failed at that. The next game, yeah, it did not go well in MMO, like myself. Never written a line of code. No, first thing I made was cubes exploding, then tried to make World of Warcraft. The next thing was I wanted to remake GoldenEye 64, which is a kick-ass game, so if you haven't played it, it's really cool. So the trouble I had with bullets kept going through walls because they were traveling too fast. So what I was able to do is I was able to pause the game, find where the bullets are, and I was able to step through, and I can see the bullets are traveling so fast, like the wall is here, and the bullet is going, it's teleporting through the wall. So what I had to do is I had to do some weird calculation to work out with the bullets just in front of the wall, and then not make it teleport, not make it move. So yeah. So we have our spaceship like that. And he falls with gravity. So I wouldn't expect people to be very happy if they paid a lot of money, like if I bought a new Halo game, and I get into a spaceship and it just falls out of the sky and just blows up. I wouldn't be very happy. So what I need to do is I'm in a problem. I want physics on my spaceship, but I don't want my spaceship to fall. So I'm going to show you a little trick or a technique that we use. So this trick or technique is to, you'll notice that the spaceship falls. The trick or technique is to basically say to your spaceship, you're affected by gravity, but not really. I know that sounds horrible. So the way that I do this is by selecting the data of that ship, going into its description, and you'll notice that the rigid body 2D has lots of options. So we've got built-in mass, we've got built-in drag, we have angular drag, we have fixed angle, we have cinematic, we have interplay, collision detection, and stuff like that. The most important one here is gravity scale. So as I play around with gravity scale, it's going to change the gravity of my ship. So currently my gravity scale is 1. So what's going to happen if it's 1.5?
Nobody knows.
It's going to fall at half the speed. So what happens if it's a minus 0.5? Or minus 10? Oh yeah, let's try that.
Yes.
So yeah, so basically the gravity scale is basically saying which direction it's going in the gravity. Is it going up or down? So the trick here is I want to apply physics to my spaceship. I don't want it to drop. So set its gravity scale to be 0, and it will just sit there. So this is really good for space games because you can have like an asteroid sitting there. If something bumps into it, it will then like move off very slowly into space. Just like, so now when I have my spaceship here, now play my game. My spaceship now has gravity, but it has no force applied to it. If I dropped like a spaceship above here, it would hit it and it would like fall off. So for example, I'm going to do this super quick. So back to get it. Right, okay, down. Right, okay, never mind. But basically, if I had like some asteroids that fell, it would hit my spaceship and apply a force to it. It's currently its gravity scale is at 0. Cool. So with the, we're going to do like some scripting and have our spaceship flying around, and then we're going to take like a little micro break. So yeah. So now that we have this component here, via scripts, what you can do in Unity, which is really cool, is you can access anything on all the components of the object. So I could go to my script and tell my sprite render to change color when my spaceship gets hit. I can tell him to go to the rotation, change the rotation when it gets hit. I can tell it to go to the rigid body, change its mass to 1,000 if you get a certain power up or something like that. Also what I can do is I can tell it to go to the rigid body, change its velocity, and then or just add a force to its rigid body to send it either left or right. And that's what we can do. So now that our ship has gravity applied to it, go to your script. Inside here, what we need to do is we're going to write rigid body 2D. So we're accessing the rigid body 2D component. So we're basically saying go to the rigid body 2D body spaceship. Dot. What do we want to do with it? So we can either go to it and we can say set its mass to be like, I don't know, 1010. Or we could say to it, go to the rigid body 2D and set its velocity to be something. What I'm going to do is I'm going to say go to its rigid body, so go to its physics, force to it, so add some form of force. And then what it's going to do is it's going to ask me for 2 things. Okay, 10 points, what are the 2 things it's going to ask me for? If I'm applying force to the objects.
Vector.
Direction and speed. Speed, yeah, because if I just give it a direction, it's going to say apply force in this direction, apply 0. Which, nothing happens. I'm going to do direction times, force. Bingo. So what that's doing is we push left, applies it to the direction, in the force, right, and applies it the other way. Super sexy. Great. Let's see what that does. Okay, so make sure you save your file. Go back to Unity. One thing a lot of people forget to do is to actually toggle the force. So currently my force is at 6.6. So what I'm going to do is I'm going to run my game, and I'm going to see what it's like. Whoa. Goodbye. So the one thing I don't like about this is the fact that it doesn't slow down. It just keeps. So if I push it's just going to do that forever because it doesn't really have a drag on it. It doesn't have anything to tell it to slowly slow down. It's like if you're playing a racing game, you take your foot on the accelerator, you eventually do come to like a stop like a Mario Kart. I don't expect to take my foot off the accelerator and my Mario Kart just drives into the wall, for example. That would be horrible. So what I want you guys to do that following along is to play around with the force and play around with the drag. So try playing around with the force on the script. So I might say like 6.6 is too strong, so let's try 5, for example. and play around with the drag. So say, make the drag to be like 2, for example. So see how that feels. Basically make it feel like you push right, it applies some force, and eventually you'll slow down and stop. Or you push left, it applies some force, and you go down and stop. So kind of like play around with it. And I think at this point where we can play around with it, we'll have a little break. Then like a little 5-minute break, not like a 15-minute break, like a 5-minute one. And then we will begin to make a rocket and animation and stuff. Go for it.
Do you achieve the same effect if you make it animatic and increase the gravity? I think I've seen something similar.
Yeah? Probably good. Hang on, so that's what gravity, that's what kinematic is about. No, okay. So what kinematic does is, kinematic kind of like locks it into place. So, so just before you guys kind of like have a mini break, you can go on Twitter or whatever, what you'll notice is next to every single component. So say like you look at this rigid body 2D, and you're like, what the hell does half the stuff mean? I mean, mass is very obvious, drag is very obvious. What the hell does kinematic mean? What does that, why is it going to sleep and stuff like that? What you can actually do is next to each component, there's a little book. I didn't notice this book was here for years, right? So what this book does is when you download Unity, it downloads the entire documentation all locally. So if you're like on a train, for example, and then like you don't have Wi-Fi because all the trains in the UK suck, basically like you can then just get all the documentation within there for the scripting reference. So say like I want to know what kinematic does, click the little book, it will open up the documentation in your browser. It's the exact page reference. So for example, here I can go down. Is the rigid body moved by forces and collisions? Basically say yes, it is, or no, it isn't. So yeah. So I can then read all about it, like what a rigid body is, and what it does, and all the stuff I can reference, and stuff like that. Which is sweet. Cool. So yeah, so I just played around my course. Okay, that's really sluggish and slow. Yeah. So if we take like a 5-minute break now, come back at like let's say 7-minute break, right? And then we come back at like 7 minutes. Okay, 6 minutes. Just get a drink, have coffee, whatever. Then we come back. Then we're actually going to bring our rockets in and shoot rockets, and then there's probably some other stuff. Yeah, cool. Thank you. We have a different.